Hello everyone, this is Team 1 and the name for our language is Mocha. As the name suggests, our language is derived from the Java programming language. Mocha passes everything in a source file between the begin keyword and the end keyword. We have implemented print statements which are simpler in comparison with the Java programming language. In this video, we'll go through the key features, syntax, grammar, and the implementation process for our language Mocha. So beginning with the key features of Mocha, we have the support for primitive data types such as int, float, boolean, and strings. We have also support for arithmetic operations such as addition, subtraction, multiplication, and divisions. Logical operations and or not can also be performed. We have also implemented looping structures such as for in range, while, and if else. The relational operations greater than equal to, less than equal to, and comparison have also been implemented in Mocha. Assignment operator and ternary operator are also implemented in Mocha. We have the Mocha also supports precedence in operator. So coming to syntax for Mocha, it's very straightforward and user-friendly. For the variable declaration in Mocha, the type specifier is followed by the identifier. For the if, else, for, and foreign range and while constructs, we put the executable statements in curly braces. The print statement in comparison to Java is much simpler. The print keyword should be followed with the string you would like to print. Coming to the flow of the language, we use Antlr as an interpreter. The .g for grammar file is passed to Antlr and that generates the visitor class. We implement the language using visitor pattern. Antlr prepares for us a set of functions to visit node of a parse tree and then we can return the user defined operation as well.
Hi, this is Zuha. I'm going to talk about the grammar interpreter as well as show parse tree. So this is the basic structure of how the grammar looks like. It has we have begin, body, and an end. The body could consist of multiple statements, and these statements are either variable declaration, assignment statement, if else, for, while, or any of the others. So this is how the variable declaration looks like. We have data type and the identifier list. So multiple identifiers can be assigned in a single statement, and then the assignment statement expressions. So a logical, arithmetic, relation, and ternary are the ones that are supported here. And arithmetic, we have multiply, divide, add, subtract. Relational, we have the equal, smaller, or smaller equals, greater, greater equals. And logical expression has and, or, and not. And then we have the if, else, for, while. So here this if condition needs to be relational or logical, and that's taken care in the implementation. Similarly for the while as well, we have this while condition that needs to be relational or logical. And then we have the print statement and the other literals, which are defined in the other slide. And this is these are the data types that have been supported: int, float, boolean, and string. These are the literal definitions, and these are the relational operator definitions, logical and ternary, and this is the identifier regex. So the interpreter that we're using is Antlr. It's a powerful parser generator for reading, processing, executing, and translating the structured text of binary files. The .g4 files generated by Antlr are very well structured, concise, with good readability. It handles the edge cases as well as suppose good reporting. And it auto-generates the classes of Lexos parsers, interpreters, visitors that are very well tested and robust. So as we see here, so these were the generated ones that these were the files that were generated by Antlr. So this Mocha based visitor was the base class that was generated by Antlr, and this is where my Mocha visitor is where the evaluation functions have been implemented, and it extends the base class which is generated by Antlr. So next is the parse tree. So for this particular code snippet, this is the parse tree that is generated. So statement 1 is the variable declaration, statement 2 is the assignment statement. So here int is the data type that is captured here, and identifier assign literal, and then identifier assign literal, which is x equals 3 and y equals 2. Similarly, here we have x is equal to 2 plus x star y. So here in the assignment statement, we have identifier operator assign, and since x star y is a nested expression, so it is that's how it's demonstrated here. So it's 2 plus x star y. So that is how it is shown in the parse tree for this particular code snippet. Thank you.
Hi, I'm Zhuoran. I'm here to talk about why we chose Java to develop our programming language Mocha and what data structures we use in this project. So, so Java is used as it is a semantically safe language and is machine efficient, as well as offers a strong type checking mechanism and automatic garbage collection. There are two reasons for we use Java in this project. The first of all, most of our team members familiar with Java, and the second is Java provides a support for extending the visitor-based class generated by Antlr 4. In our case, that is my Mocha visitors. I think the team of Antlr 4 did a great job for connection with Java because uh, they use they use a visitor pattern to connect the parser tree, which provides the convenience to the developer or the user. So in our case, our evaluator function are written in the my Mocha visitor class. And in this project, we define the two data structure to store the semantic arrow and the variable. The semantic arrow list will captures all the semantic arrows that arises upon execution of the code, and we also use hash map to store the variable, which could store the identifiers and the variable in the form of key value pairs. So in that ways, we can use advantage of the hash map to easily identify the semantic arrows.
Hi, I'm Shengdong Chen, and I introduce the runtime evaluator for our language Mocha. And basically, we're using visitor pattern to evaluate the parse tree. As you can see, those are the functions we have implemented for every non-terminal nodes in the parse tree. I'll give an example to explain more. So basically, this is a short program which has only declaration statement in it. So our software is gonna visit the program first, which is gonna be the whole thing, the 3 lines as total, and then we're gonna visit the body, pass the body into the body visitor. The body is only int x, and then we're gonna pass the statement in the body into statement visitor. In this case, there's only int x, so we pass the int x into the statement visitor, and then it is variable declaration, and we goes into the declaration visitor, and then we're gonna evaluate its data type and its identifier list. The data type gonna tell like what kind of data type is it. It's int, string, or boolean, and in the identifier list, it's gonna determine if it's a single variable or multiple, because we support the functionality that we can declare multiple variables, for example, like int x, comma y, comma z, like that. And after the compilation, you can see on the right, that's our output. Actually, that's the map, our variable maps. So after the declaration, we have our variable x with int value 0 as default. And then this is an example of the assignment statement. As you can see here, is x equals to 1 plus 2 times 3, and our visitor is, we're gonna first visit the assignment statement, and then we know the x as identifier, the equal as an operand, and then the rest of them are expression. And then the expression gonna pass all of the expression into arithmetic expression, and then this one is gonna return the value of the whole expression, and as expected, it should be 7 with precedence. And then the arithmetic expression gonna return the value 7 back to the assignment statement visitor, and that one is gonna change the value, probably assign the value 7 to variable x. And basically that's how our evaluator works. And the declaration visitor and assignment visitor are the most important one, because those are the tools that manipulate our variable maps. And then let's have Rishabh to introduce our language more with running samples.
Hi, this is Rishabh here, and I'll be walking you through the software which I developed. So just allow me a moment, let me share my screen. So this is the GUI of our application. This big text box on top, this is the code editor. We can just type in the code here, and the small box here down. So this is the output area. It displays the program output and some intermediate output about parse tree and the errors in the program too. The small area here, it represents the environment. It will show you the variables which is there in our current environment, the data type and its value. So just let's get started with a small program. I'll just copy paste this here. So this is a basic program. It deals with evaluation of expressions. So a very simple one, like we have defined in 2 integers and the third one. So third one being assigned like a plus 4 into b by 2, and then we just print the value. So let's try what happens when we run this. And we see like it says like program parsing successful. This means that everything went well and there's no syntax error. And this is an intermediate output about the parse tree. And evaluation successful indicates that, okay, the evaluation happened properly. And yeah, finally, we see that the value of C is 30. That's what is the expected of the program. And here in this side, you see like we have variables, the types and values. So like, yeah, it's like A is 5, B is 3 as we have defined, and C is like A plus 4, which is 5 plus 1, 9 into 2 into 3, 27 by 2. It's 13 because it's an integer. So in our programming language, we also have the concept of implicit typecasting, and we'll see how that works. So let's make B a value of type float. So float B equals 3, and we'll remove it from here. And let's see what the output is now. So again, you see that C is not changed because C is still an integer. So implicitly, this expression is evaluated in floating point arithmetic, but then it gets converted to integer. So let's try making C a float as well. And so that's the magic there. It becomes 13.5. So like now C is the like it's evaluated with floating point arithmetic. Let me quickly show you another small example. So this is a small program with the Fibonacci series, and like it displays the first 10 Fibonacci series, Fibonacci numbers, sorry. And if we click run, you can see here it's like 0, 1, 1, yeah. And again, as I said, like this section represents the environment. Also, we have provided a functionality that you can load source files into this editor. So just go to menu, click load, and then let's browse, go to home, and just move the samples. Let's take this program. And yeah. So this is a sample program which like calculates your BMI and prints if you're overweight or you're normal. So yeah, so by loading the file, the entire code just got loaded in this editor, and you can click run, and you see like the same thing, parsing, parse tree, and like program output along with the environment values. So that was most about our application. I hope you liked it. Thank you.